everyone. My name is Natalia, and today I will present an experiment that we conducted that is titled Standardized Ileal Digestibility of Amino Acids in 4 Egg Products Fed to Weanling Pigs. First, I'll start with the introduction. We know that weaning is a stressful time due to the transition of milk to solid feed and due to the underdevelopment gastrointestinal tract, and also because of the lower digestive enzyme secretion that leads to limited absorbed capacity. So the inclusion of highly digestible protein is critical in weanling pigs because it can enhance nutrient absorption, support optimal growth and development, and decrease post-breeding diarrhea because it avoids the excess of undigested nitrogen reaching the hindgut. Egg proteins have been used for weanling pigs as an alternative to other protein sources like soybean meal or spray-dried plasma, because also due to their favorable amino acid profile and also due to gut health and immune function. However, some considerations must be taken when using egg proteins, and this is because of differences in processing that can differentiate in chemical composition and also digestibility, and also the presence of protease inhibitors that are not always deactivated with heat treatment. So here we have proteins of the egg albumin, that we have albumin, ovotransferrin, ovomucoid, ovomucin, and lysozyme. Some of them are not heat stable, meaning that they are readily denaturated with heat. However, ovomucoid and ovomucin, they are heat stable, meaning that they are not denaturated with heat. Therefore, ovomucoid is a major trypsin inhibitor, preventing the degradation of proteins in weanling pigs. How do we measure amino acid digestibility? We first have protein that is broken down into amino acids that are absorbed before the end of the small intestine. And ileal digestibility, it's a more accurate measure compared to fecal digestibility due to the not influence of microbial protein. And also, the standardized ileal digestibility is the gold standard method for evaluating absorption of amino acids in pigs. So then we come up with the question how differences in processing of eggs can affect the SID of amino acids. So for this, we conducted a simple and small experiment with the objectives of determining the SID of amino acids in different heat-treated eggs, with a hypothesis that the heat-treated eggs are high-quality proteins when fed to weanling pigs, and the SID of amino acid in trypsin inhibitor-free egg does not differ from the SID of amino acid in casein. Moving on to the material methods. So first I'll talk about the test ingredients that we had. We had one source of raw egg powder. Second source was a dry pasteurized egg powder. The third product was a liquid pasteurized egg powder. And the fourth product was the free trypsin inhibitor egg powder. And we also used casein as a comparative protein to evaluate amino acid digestibility. The diets included one source of egg in each diet, and also the source of casein to formulate a diet to 18% of crude protein. And we also had a nitrogen-free diet where we used to measure basal endogenoous losses of amino acids. The diets also contain chromium dioxide, where we used in the calculations of digestibility. For this experiment, we used 12 nursery pigs with an initial body weight of 12 kilograms. Moving on to the digestibility experiment, we had a replicated 6x6 Latin square design with 12 replicate pigs per treatment, and we had a 7-day period, and that was 5 days of adaptation period to the diet, and the last 2 days were the collections that lasted 9 hours each day. For the statistical model, we used Proxmix and SAS. The experimental unit was the pig, and the fixed effect was diet, and the random effect was period, square, and period. And we also considered the results significant at p less than 0.05. Let's move on to the results and discussion. So I'll set up the slide first. In dark blue, we have crude protein. In medium blue, we have hydrolyzed fat. And in light blue, we have ash. So as you can see, the concentration of protein varied in CP and amino acid composition. And this is maybe a result of the processing methods used to manufacture each ingredient. As you can also see here, the liquid pasteurized and the trypsin inhibitor activity-free egg had a slightly greater concentration of fat compared to the other eggs, which may reflect differences in liquid pasteurization or raw material sourcing. At the end, we can see that the trypsin inhibitor activity-free egg had higher X, which was expected due to the steps intended to inactivate the trypsin inhibitor activity that involved thermal and pH treatment with organic salts. When we look at the trypsin inhibitor activity in dry matter basis in milligram per kilogram, we have here in blue the raw egg, in orange the dry pasteurized egg, in purple the liquid pasteurized egg, and in gray the trypsin inhibitor amino acid free egg. Here you can see that there was a reduction in trypsin inhibitor activity, and also at the end a reduction of 90% compared to the raw egg for the trypsin inhibitor free egg. When we talk about the SID of indispensable amino acid, here is the same color pattern as before, but we also have casein in blue. So the first thing I want to point out is that SID of CP and amino acid in casein was in agreement with previous reported values, meaning that they were close to 100%, confirming the validity of the current result and supporting its use as a comparative protein. So as you can see here, the SID of CP and most indispensable amino acid and trypsin inhibitor amino acid free egg was not different from casein, probably because removing these inhibitors likely allowed digestive enzymes to more effectively hydrolyze proteins, which increased amino acid absorption. However, that was not the case for the other eggs. Then it's due to likely that they had the same digestibility due to the presence of the ovomucoid proteins that are heat stable. When we look at the other indispensable amino acids, same story here. The TFE had the trypsin inhibitor free egg and casein was greater than the other products, but that was not the case for the other eggs, that it was lower than the trypsin inhibitor free egg because the temperature used to produce them was likely not high enough or was applied for too short time to inactivate significant part of the trypsin inhibitors. I also would like to point out that pasteurization uses relatively mild treatment and are designed more for microbial safety than properly inactivation of antinutrients. This clearly demonstrates that trypsin inhibitor in eggs, like ovomucoid proteins, reduce amino acid digestibility in pigs. Some practical applications with this is that the target reduction of TIA was more effective than pasteurization, and that lead to the increased SID of amino acid in weanling pigs. But although it's well established that the heat treatment reduces protease inhibitors, the temperature and duration of heating at which inactivation begins remain unclear. So this distinction is important as the standard of ovomucoid inactivation likely contributes to the improvement in the digestibility of amino acids. Also, I would like to point out that these experimental diets had a high inclusion percentage of egg proteins, and that is not common in commercial diets, and this was because we needed to include these proteins as the only source of amino acid. With that inclusion, this is how much we had of trypsin inhibitor activity in the diet, but in commercial diet, the inclusion, as I said, is much lower, with an inclusion percentage of 3 to 5%. And when we calculate the inclusion of trypsin inhibitor in the diet, we can see that the concentration of trypsin inhibitor is similar to the trypsin inhibitor activity-free egg. And then SID of amino acid in the dry and liquid pasteurized egg may be compared to the trypsin amino acid-free egg. Some overall conclusions is that, as I told you before, all egg products had SID for most amino acid exceeding 80%, and that the trypsin inhibitor activity-free egg had SID of amino acid that's not different from casein, and the trypsin inhibitors reduces the SID of amino acid in egg products. So how does the free egg compare with other processing eggs? You may be wondering if there is a difference in different heat-treat processed eggs. So importantly, not all eggs subjected to thermal processing retain significant trypsin inhibitor activity, and the extent of the ovomucoid inactivation depends on the intensity and conditions of heat treatment. So as you can see here, we had an experiment that we conducted, and we had fried eggs, boiled eggs, and scrambled eggs, and this demonstrated that certain cooked products are similar to those to the trypsin inhibitor activity-free egg that we had in our experiment. So this reflects the fact that conventional cooking methods expose eggs to higher temperatures than mild processing, such as pasteurization, unfolding protein structures, and also increasing access to digestive enzymes, thereby improving amino acid digestibility. So with that, I would like to thank my team for help conducting this experiment, and also would like to thank Simrise for financial support of this experiment, and I would like to thank you. And if you want to know more about our research, you can check out our website.